in the photograph, which will change what you can see.
Right,
so I'm afraid,
right.
unless you
so
can, this is the sort of experiment. Hold on. This is the sort of experiment. Hold on. This is the sort of experimental error that flatties do because they don't consider all the variables. Now, go ahead.
So basically, you're moving the globe post.
No, I'm citing a material existing problem.
You
used
the light isn't only going through air particles; it's going through the entire atmosphere. So again, my question is, how does the refractive index stay constant at 1.0002, passing through a density gradient of air for 10 miles?
I'm going to stop you right there because you're going.
Even if it's 10 miles, that is a gradient. So it's actually getting a.
You're going through the absurd here now, Red, and I'm not going to sit here and just let you do it. Do you agree, Red? Hey, high IQ guy.
Science isn't absurd, Bob.
No, your interpretation of it is
with your Snell's law calculator.
So the other day I was messing around on YouTube and I saw a live debate from the Jose J.G. Gonzalez YouTube channel. And the Globetards on the panel were discussing recent videos that have been circulating where people put a flashlight at one end of a hallway. They walk 400 feet to the other side of the hallway. And then they lower their camera down close to the floor. And the light disappears even before the camera even touches the floor. And this is, on the flat Earth side, this is a possible explanation for why ships disappear bottom up. But if you're a globetard, as always, you must deny reality and science. It's just sad. Like we're talking about like science and reality here. Like you can't like deny this. I mean, you guys trying to take us back to like the dark ages here. We need to be with the science and the evidence. Like you guys are trying to take us back to the dark ages, and it's sick. And it's just sick, man. Like just sick. So I was just so appalled by the fake news that I was hearing in the debate that I decided to jump on in, and it ended up being like a 7 versus 1 debate. There was another globe skeptic on the panel, the Mind of God, but a lot of it was just me going back and forth with, we got the usual suspects. So I'm going to go ahead and play it. This is basically an excerpt, and be sure to check out Jose J.G. Gonzalez's channel. He does live debates basically every day. He told me I was allowed to upload this excerpt, and at the end of the day, his debate show is great, but it's basically like a safe space for globetards who are afraid to debate Nathan Oakley. So it's really funny to watch. It's kind of like an Alcoholics Anonymous meeting or something. Like it's just a bunch of beat up people who've gotten destroyed in debates, and they're just like all quiet. They're like, "Yeah, man, Earth's a globe. Nathan Oakley's mean." So anyways, guys, the link is below to Jose's channel, and enjoy this 7 versus 1 debate.
Yeah, right here. You see that? I see the light.
We're talking about living on a sphere that curves.
Right. I see the light,
all the way around,
and the light is gone. You see that?
And here, then they basically start arguing that the reason the light disappears is because construction crews aren't capable of making flat surfaces in big shopping malls and corporate buildings. And that the reason the light is disappearing from the bottom up is because the floor is uneven.
Go onto your floor. When you finish in here, go and get something long and thin, or go and stick your eye on the floor in your kitchen on something that's not carpeted, and you will be amazed how much of the bumps you can perceive.
Of other people have caught it, because why not? I mean, now, do I say there's
people? You guys
people?
Hear me?
Hey, hello, Red. Yeah, welcome. Loud and clear,
Hey,
brother.
what's up?
Lord, Red Bill.
The claims is made that there's people up there and is this height and all that stuff. I cannot prove anything of that. Is there a shaped light that go as predicted on a website? Yes, there is. I mean, that's all I gotta say. Welcome, Red Bill. Glad to have you here, brother.
Hey, I just wanted to present something real quick. You guys were talking about lights disappearing in the distance when you place it on a floor. I wanted to present a bit of a counter argument. Is that all right? Can I share my screen?
Go for it.
Okay, here we go.
Let's hear it. Let's hear about angle of attack.
All right, so can you guys see my screen? Okay, great. Good. Go ahead and, okay, we'll leave that there. Okay, so somebody went out and they did a little test.
They wanted to see, because what I hear from you guys is that the reason the light disappears is because the floor is uneven. So, okay, well, wouldn't an interesting test be to maybe get 2 cameras, put them at the exact same height, and see if the light is visible in both cameras? Now, to be specific, the aperture sizes of these 2 cameras are different. And this is important because the argument from the flat earth side for why the light disappears is not because the floor is uneven, and it's not because the floor is curving. That's for damn sure. The flat earth argument is that it has to do more with the physics of light, vision, and the viewing instrument you are using, like the camera in this case. So somebody went ahead, they went to a long hallway, they put a flashlight on the floor, I think it was like 400 feet away. They put 2 different cameras. One was a big Canon, I forget the exact, I think it was a Canon EOS 70D with a big ass lens. And the other one was simply a little iPhone with a tiny little lens on the back of the iPhone. They put the 2 cameras at the exact same height. And well, this is what happened. I'm gonna go ahead and play it.
Hang on, was the floor perfectly flat?
Well, this is where I'm going to debunk that stupid bullshit argument right here, right now. So let's watch.
Oh, okay.
So this right here is the footage from the Canon EOS 70D.
And do they have the same? Hold on, do they have the same F number? The state did have the same F stop on them.
It'll take me a second. I'll be done in a second. You can see the flashlight in the Canon EOS 70D. There it is. You see a little blink of light there. Now he's going to put his iPhone 6S on a stack of papers, which he measured to be the exact height of the Canon camera right next to it. And he's going to set the iPhone 6S down on the stack of papers so it's elevated at the same height of the other camera. And it's going to not be visible in the iPhone, even though it's visible in the other camera right next to it. So let's watch.
Question real quick.
Yeah.
Are the measurements from the floor to the lens, are they being measured from to the center of the lens?
It's measured to the center of the lens. It's also taken into account, obviously, the body of his iPhone 6S.
No, that's irrelevant. I'm saying, is the measurement the same from the floor to the center of the lens?
Yeah.
All right. Continue.
Okay. So he had just placed it at the same height of the other camera, and go ahead. Now he's zooming in, and you just cannot see the light.
It's a lower resolution and a lower f-stop number, you utter moron.
That's the point. Two different cameras at the same height over the same floor, visible in one, but not the other. Now, hang on. Rumpus, this is big. He's going to lift the camera higher now, and it's going to come into, it's going to be visible again. Watch. Camera then lifted off the paper. Watch. And now there is the pinprick of light. There it is. What changed? The only thing that changed was that he lifted it higher up, changing the angles involved, which is exactly what the flat earthers have been saying now about this whole phenomena. Two cameras, different aperture sizes, different lens sizes at the exact same height. It disappears out of one, but not the other, and then reappears in the other one once he makes it higher, changing the angles involved.
But the floor is not perfectly flat.
No. More importantly, well, when you're on an airplane, what is the sun set?
Okay, you're deflecting to some other methods. We're talking about the floor examples and the hallway examples with the light at the end. This is what we're talking about.
Yeah.
Well, given this is a flat Earth, we know they're going to be incompetent. I mean, this is what Riley gets things every single time.
That's just a silly ad hom.
No, it's not, because it's absolutely true. It's absolutely true. You can things like Riley, when he goes to things like measure slopes and things, he always does something stupid. Same with Ranty. Same with every flat Earther I've ever met.
Look, you're appealing to some unknown mistake that he might have made.
Yeah, but it always happens. And so I can't rely on any of the experimental method here. But anyway,
we need some Globers to go out and reperform it, because you guys always appeal to the floor is uneven. The floor is
but hold on. This does not.
I never said that. Hold on, Red. Look, I never said that before. What I said is, if you increase your elevation, you're saying you can bring the sun's light back into view. So why is it that we go high up, as high as we can? It doesn't matter how high we go at one point of the Earth, we will never bring the sun back. So you're saying that light is infinite, but it's just that the floor's in the way because of perspective.
Actually went out and did some really good experiments.
Let me answer my question. Bill, try to listen to what I'm saying and then address what I'm saying. What you're showing me is an example. Hold on.
You guys were talking about hallways and observations in hallways with lights. Jose presented his video, so I'm coming here to present a similar hallway test observation, and somebody who happens
you're supposed to replicate what we see in reality. What you're trying to do. This experiment supposed to replicate what we see in reality.
Why are you deflecting, dude?
Tommy, you got a very bad mic, Tommy. You're gonna have to stay on mute, bro. You got to.
Why are you deflecting, bro?
I'm not. I'd like to answer your point. There's another issue, of course. When this will have an automatic aperture being on an iPhone, so you won't be able to fix the aperture on this. And so, of course, as you move it up and down, you'll change the lightness of the image, and therefore it'll change the aperture to keep it.
Right.
So you have an automatic exposure. Hold on. Let me finish my point. Hold on. Let me finish my point. You're not letting me finish my point. So just like you have automatic exposure, which means that some things will become less visible. So depending on what you're looking at, it will change the exposure because you can't fix it. Whereas on your Canon, you could, which means that just by moving it up and down, you're changing the amount of white in the photograph, which will change what you can see. So I'm afraid, unless you can, this is the sort of experiment. Hold on. This is the sort of experiment. Hold on. This is the sort of experimental error that flatties do because they don't consider all the variables. Now, go ahead.
So basically, you're moving the globe post.
No, I'm citing a material existing problem. You used hold on.
Let me respond.
Did you not understand what I said? Did you not understand what I said?
I let you talk for 40 seconds.
Yeah, but you clearly didn't understand what I said.
Let me just say.
Did you understand what I said? Did you understand what I said?
Before I came in here and provided this counter evidence, guys
did you understand what I said?
The floor is uneven.
Yeah, I know, but did you understand what I said?
Now it's
but you've changed. You haven't given a constant thing. You've now introduced a new thing when you're moving the camera up and down and changing what you're looking at. And if you understood what I said, you'll understand the camera on something like an iPhone is changing its exposure all the time. Now, if you'd fixed it with another camera, with a smaller camera, where you fix the exposure, which you can do with good cameras, you wouldn't have this problem. But because you're using an iPhone, a grotty little iPhone to do this, it will be changing its exposure, which means still things will be perception or not.
Let me get this straight. You are telling me that the reason the light came into view when he lifted it up like a couple inches off the paper in a closed a building with consistent lighting all across, you're telling me because the exposure suddenly changed, and that's
I'm saying this could be a factor.
That is ultimate moving of the globe post.
No, it's not, because if you're moving the camera, you're changing what the camera sees, and it will change the exposure.
Rumpus, before you said exposure, before you said exposure,
can I make a point?
You said exposure, you said it was due to some error that flat earthers make.
Come on,
I didn't know you were going to move the camera.
Hold on a second, Rumpus and everybody.
You're going to do that.
Hold on a second, Rumpus and everybody. Tommy, what is going on? What is wrong with you, bro? You got a bad mic. You got to stay on mute. I appreciate you in the panel, but you cannot be speaking over and over everybody because you're washing up all the sound. Bro, no. You're just making noise because it's not understandable, bro. You gotta stay on mute, Tommy. I'm sorry. When you sort out your microphone, bro, you're doing it again. What the fuck is wrong? You know, I'm talking and you're talking over me. That's what you're doing, Tommy. Come on, man. Respect, bro. You're welcome. Everybody's welcome. But what the fuck are you doing? Can you even hear me talking?
Yes, I can hear.
Then shut the fuck up, bro. Let people talk, bro. Shut the fuck up, bro. Let people talk. People is talking and you're just shouting over them. Come on, man. Stay on mute, brother. I appreciate you. Come back when you sort your mic, bro. You can step out now. Thank you.
My mic's fine. My mic's fine. I just want to say one thing, and that was it. And you're just giving me loads of shit.
Yeah, but Tommy, this was the same thing in Nathan Oakley's show earlier. Like, you get so close to the mic that when you shout, like, it crackles and pops. Like, if
it is distorted, Tommy.
If it is distorted, maybe you'll be all right.
Your microphone is distorted, Tommy.
Plus, what you say sometimes doesn't make sense, so it magnifies the worst one.
It is crackly, Tommy.
Point. All I was going to make is that he's trying to say this experiment replicates what we see in reality.
I know you want to interact, Tommy. You want to ask questions, but it's understand. We cannot understand what you're saying. You got a really bad mic. Sorry.
Hey, Red Pill. So I have something to add to point out too. That even though both of the lens are, the distance from the floor is measured to the center, you do realize that the iPhone camera lens compared to a DSLR, the DSLR has a lot more real estate. It's bigger, and if this is the center, and if you compare the iPhone lens to the DSLR lens, which is bigger, you still have a lot more height, and relative to the space. So you still can have some light that will reach the DSLR lens, but not the iPhone lens.
Okay. Well, first of all, what does that have to do with when he lifts it up a little higher, the light?
Exactly. So if you have a DSLR lens right here, and you're getting some light, reaching here, and you have the iPhone lens right here, and the light's not reaching. When you lift the iPhone, then the light will start reaching it.
Yeah, I actually think that's literally the flat earther argument. Thank you.
Well, no, it's not, because he's saying that the lens on a big camera is obviously much higher. So you're going to be collecting light all the way to the top of the lens. Whereas on an iPhone, it can't collect lens except to the top of the lens. And that's going to be much lower.
So you're telling me that what you can and can't see is observer dependent, not curve dependent. Thank you.
Well, no. Oh my gosh.
But it doesn't account for things being obscured.
Appreciate it.
No, surely you understand that the top, a big lens is bigger than a small lens, and it collects light from all parts of the lens. So if the iPhone lens is low down and being, hold on, let me finish. Let me finish, please. Hold on, let me finish, please. Hold on, let me finish. You haven't let me finish. Wait, hold on. Can I just finish the point?
Yeah, sometimes anybody finishes their point. Sometimes people is caught out, and you gotta then hold the thought, and let the other people speak. It's okay. Sometimes I don't finish my thoughts 90% of the time. I start speaking and somebody starts speaking and I gotta just lay back. You have to be humble sometimes and learn how to shut up, Rumpus. I know you want to finish your points, but you gotta take it easy on everybody, bro.
Jose. I was in the middle of an explanation.
All right, let's go ahead and give the floor to Rumpus and let him finish the thought.
I just wanted to finish my sentence, right? Which all it is, if you can understand it, with the iPhone case, it can only collect light coming in from the whole of the lens. And that lens is clearly much lower, whereas with a big lens, it's collecting light from the top of the lens. So it will be able to, and now this also all depends, of course, on the floor not being flat. If the floor was perfectly flat, this problem wouldn't exist. I accept that.
Rumpus, check out my video feed. For reference.
Nice sentence.
So the point is, if the floor is wiggly, then the bigger lens will, because it collects light from the top of the lens, which is much higher up than on an iPhone small lens, it will therefore pick up light that the iPhone wouldn't. But it is dependent on the floor being wiggly. If the floor was completely flat, I would accept that both should pick it up, except for the F numbers. And the height, therefore, shouldn't make a difference. But I do not believe this floor is completely flat. I'll finish.
Okay, Rumpus, check out my video feed.
Can I shortly add one point? Can I add one point?
Hold on, Red Pill is remodeling.
There's a high IQ presentation from the
high IQ.
Life is short. Everybody go check out this stunning presentation. It actually gives you a highly scientific breakdown of why the light disappears bottom. As you can see here, guys, I mean, it's very complex. You got to look into it very deeply. It's not as easy as when you're a globetard, you just call things curvature.
Yeah,
but when you're actually like high IQ and you actually look into things deeply and scientifically, you see that it's very complicated. Look at it.
This is done by an idiot. This is done by an idiot.
Who's making noise, please? Who's laughing and making noise? You don't let in Red speak, guys.
The kind of research you have to do when you're actually into the real truth of the nature. Look at this. I mean, this is intense stuff. You guys got to go.
This is done by someone who doesn't understand perspective.
Look at this. Look at it. You can't just shout curvature.
Yeah, no, this is bollocks. This is done by an idiot. This is done by an idiot who doesn't understand.
Red. I want to give Red a chance to tell everybody where can they find this video, because we know you're not going to be able to explain it and break it down the way you want because of so many people here. Where can they find this video and what does it explain, please? Everybody, please stay on mute.
Thank you very much, Jose. I really appreciate it. Listen, everybody, there's a YouTube channel called Life is Short. I put the link into the chat a few moments ago. He goes over it in hour-long presentations, 3 hours, 6 hours. They're incredibly detailed.
I had a look at that, and it's utter
bollocks. Guess what, guys? You're gonna have to come up with more than just
I've looked at this.
curvature.
It's done by an idiot who does not understand perspective.
Shout curvature as an explanation for everything. You're gonna have to get into deep science.
I have. This is not science. This is bollocks. I've had a look at this. It's utter.
So I'm gonna go ahead and post it into the chat.
Look at that statement. Look at that statement. Hold on. Look at that screen grab you just had then. Perspective represents our linear world by coupling exponential height change with exponential distance.
That is
completely and utterly wrong. That's done by an idiot.
Your view is right angle triangles dictates everything along a flat surface?
Yeah.
Is there any chance I can give him that view now?
Yeah, those are exponential lines.
But the mic still distorted, yeah?
That's done by someone who doesn't understand perspective at all. I mean, this is utter drivel. Utter drivel. See, yeah.
Did you see what I was trying to show you on the camera?
Oh, sorry, this is Carlos. Yeah, your little diagram, the blue, your business card thing.
Yeah, do you see that?
I think you're describing what I articulated. I think, Carlos.
Can we get that's what I was trying to help you.
Right, thanks, Carlos.
Is that better? All right. Red Pill. This experiment you bring in is to replicate what we see in reality. And when you increase the elevation of the camera, you're saying that when we increase the elevation, we should see the sun appear over the flat Earth. But one thing that I know, no matter how high you are in the air, the sun will disappear. So are you saying that when we're above the clouds in an airplane flight, that we should still be able to see the sun? But that's not what we see. So even though this experiment you brought is to replicate reality, if reality is a flat Earth that's appearing to be curved because of these reasons that you've given, I want you to answer the question.
Well, I never
the sun sets when you're on a plane.
Analogous to the sun. I'm saying it's analogous to the assertion that that's why ships disappear bottom up.
And that's why the sun apparently disappears through the horizon, right?
No, they're not exactly the same. They're kind of different arguments.
Yes, why is there a? Can I ask a question? Why is there a different rule?
He's not done yet, Laurie.
So rude, dude. There's a vanishing point, which is what I would say is the reason the sun sets. And I would say that's what the horizon is. The horizon is the vanishing point. It's not like the peak of a bowl of water in the distance. It's absurd.
Isn't that the same rule as for the ships?
I'm sorry, Laurie, what was that?
Isn't that the same rule as for the ships?
It's similar, but when someone says that no one's saying the sun is disappearing bottom up necessarily. We're just saying it's disappearing into the vanishing point.
So,
but that doesn't make sense on a flat Earth.
Oh wow, you guys are so rude, interrupting me.
What is the difference between the 2 points?
I guess I can't.
What is the difference between the 2 rules?
I'm sorry, sorry, say that again.
What is the difference between how ships disappear and how the sun disappears?
I mean, like I've said, it's basically the same thing, but the ships disappearing bottom up is very specifically about bottom up disappearance. Technically, that's essentially probably what is happening with the sun, but it's a little different with the sun because the sun is so high up in the sky that the perspective rules in place are going to be much different.
You see how crazy this is?
That's the beautiful thing about the heliocentric model.
Because what you're saying, Red Pill, is that this experiment, right, proves the boat's going over the horizon, but then when you imagine the sun above this in this experiment, because this is supposed to replicate reality, is what you've brought to the table, right? You know, the sun is always above the earth, yeah? Wherever you ever witness it, no matter where you're on the earth, the sun is well above the clouds. But when you go in a plane, which is very high to scale to what you're showing on that video, the sun still sets. So
Why wouldn't it set? Why wouldn't it set in a plane at 30-something thousand feet? You can barely even make out curvature, and you can barely even make out the horizon of allegedly dropping below eye level. So it's basically inconsequential. You still have a horizon line in the distance. When you look out your airplane, listen to me.
Calm down. Not only does it set, when it appears to go below the surface of the earth, it creates light on the bottom of clouds, showing you there's an angle of light coming from beneath the surface of the earth.
Tommy, I have a question for you. Do you think the horizon, let's say you're standing out at the beach, you're looking out at
Hold on, Red Pill. Please don't ignore what I just said. Address what I said, and I'll answer anything you like.
All right, go ahead. I couldn't say
when the sun sets, not only does it appear to be setting, it goes beneath the surface of the earth and casts light on the bottom of shadows, which you can observe from the airplane. So, all on the ground. So, I need you to understand that that's impossible on a flat earth.
No, please let him explain without interruption.
Wait, I need you to say it again. So it's going beneath the earth and it's lighting clouds? What are you talking about?
Yeah, you said light up beneath the shadows or something, dude.
He meant beneath the clouds.
Yeah,
right. The sun goes below the horizon, appears to be going beneath the surface of the earth.
But from a plane or from the ground?
Let me finish talking, and then because I have to slow it down because you haven't heard. I don't want to talk on the mic long. I've explained this twice very clearly. This is my third time. Slowing it down for you, right? The sun appears in your world to go beneath the surface of the earth, and there is an angle of light that illuminates the bottom of clouds, and we can agree that nowhere on the earth do we see the sun appearing to be beneath the clouds. But the sun's light is traveling in direct lines in parallel to where the sun apparently is, and illuminates clouds from underneath. When you're on the plane, you can also see the sun set and illuminate clouds from underneath. How does that work on a flat earth?
It's been demonstrated. I think it was Rob Skiba.
No, I'm asking Red Pills. I'm asking Red Pill for his interpretation.
Let me get the clarification I needed. So, are you talking about from a plane or from a ground? Where is this phenomena taking place?
You see this phenomena no matter where you are.
I'm showing it now. The very phenomenon that he's talking about. Can you see this? Oops.
Present.
There's the picture.
Rumpus.
Whoops. I just damn it. There we go. Here is an example of the shadow of a mountain falling on the clouds above it, and because the sun is clearly below it. You can only have this if the sun is below the mountain and the clouds.
Beautiful.
So that's impossible on a flat Earth, simply sorted.
So just let me just stare at that picture for a minute. Let me just take a look at it.
Yeah, take a look at it. Soak it in.
Yeah, I mean, I don't know if you can like present yourself, Rumpus, or something. Let me just take a look at that.
Well, you need to click on my avatar.
All right, I got you. Okay.
I'll put it in my illustration program as well to make it a little bit easier to show you.
I don't know. I mean, that's kind of interesting. I immediately have to wonder.
Interesting.
Oh yeah, I mean,
interesting.
It's okay for things to be like kind of like when I showed you guys the light disappearing out of one camera, not the other. It's very interesting what happens when you actually look into things.
On a bendy floor, yeah.
I'd have to ask myself, how does the angular size and distance of the sun affect how the light is cast in distance, and how that affects it passing through the mountain and casting a shadow?
The sun is below the mountain. The sun is below the mountain.
Yeah, Red Pill, that's kind of interesting you bring up the angular size of the sun. It's kind of weird how on a flat Earth, if the sun is above us, it doesn't change in angular size throughout the day, but also maintains 15 degrees per hour. Isn't that interesting? How does that work?
think the horizon is just a bulge of water? You guys actually think that when you're standing on the beach and you look out at the
Hold on, guys. He's answering and you're interrupting.
Of a bulge of water.
You're deflecting.
You're deflecting, Red Pill. You're dodging his question.
Order in the court. Order in the room. I want to hear. Order in the court.
Answer me that question.
Really quick, Red. Order in the court. I want to hear Red and Timmy interact a little bit because I think Timmy is going to present you some images. I want to hear your take, but I want to see.
Hang on, I entertained.
Yeah, so Red Pill, as he was saying, 26 miles away. This is
picture. So it's now. Let me get my question in because I entertained this little mountain picture from Tommy. So let me get my thing in. My question for you guys is: do you really think that the horizon? Let's say you're standing on a beach, you're looking out at an ocean.
Yeah, look at my picture before you say anything.
Do you guys really think that's the leading edge of a bulge of water, the sphere? Is that what you guys think the horizon is?
Okay, let's hear him answer, and then you interact with Timmy for a minute. I want to hear this. Go ahead, answer that question.
So Red Pill, as you can see on my picture here, this is looking at Salt Lake City from 26 miles. I've done this like 10 times. And as you can see, there's a bulge of water that actually comes up and starts to obstruct. Well, I guess you're going to talk over me. Go ahead.
God, dude, this old fucking picture.
No, actually, I have a lot more.
Yeah, man, present something else. This shit's old and stupid.
But how about it forward?
Before Red Pill about people talking over you, let him present.
Yeah, Red and Timmy, can you talk for a minute? You know, like talk and let talk, and then talk and let talk. Can we do that, please?
Is he going to answer my question about horizons?
Yeah, obviously in this picture here, and this picture is still relevant, and I have tons of pictures. I have hundreds of gigs of observations from the Great Salt Lake, Lake Tahoe, and other places, Red Pill. So this is still relevant, obviously. Yes, there's a bulge of water that actually comes up, obstructs 220 feet of this building, as well as 100 feet that leads up from the water's edge up to the building. Okay, so on a flat Earth, we wouldn't expect this.
Retard.
Wait, can I ask a question about this picture?
No, Red Pill and me, the close-eyed Cyclops guy right here. Let's go, dude. What's the answer for flat Earth?
Like, I've seen this get debunked 1,000 times.
By who? It still hasn't been debunked. It's a fucking picture.
The other day when Nathan Oakley cupped you live, it was incredible, bro. This shit's long debunked.
How did he debunk the observation?
Yeah, go on, repeat the debunk. Repeat the debunk.
Yeah, what's the debunk?
Well, geez, they started getting into so many things because.
Well, do one. Give one.
Give one.
I mean, they were talking about compression.
Cyclops, give one.
They were talking about the potential compression of the buildings into the distance. They were talking
about potential. Okay.
You can say something compressed.
Why do you guys deny compression?
Right, so it's compression is your answer, is it?
You guys deny compression?
Oh, hold on, is that your answer?
I got a video from Mick West. He said it's real.
So you think all the missing parts of the building are compressed?
Let's stay on track. I'm trying to talk about the picture.
Oh, that pussy rage quit. What a faggot.
Right, so Red Pill, your answer is, I've got a similar picture to that one. I can go, I can show you.
Well, hang on. Is anybody going to answer my question about what they think horizons are? Do you guys actually think
the thing is, you deflected from my clouds, didn't you? You didn't answer the clouds thing. You moved to a new subject.
I let you present your image, and I gave you my response and said, yeah, I probably need to longer.
So you did not give a response to
that. It was interesting. You just said it was interesting, and that was it.
Yeah, I did. I mean, I'm not going to say it proves the globe. I'm not going to say it proves the flat Earth, but I do want to think about it a little bit longer.
I can actually answer your question regarding the horizon.
It definitely contradicts the flat Earth. Regardless of what shape the Earth is, this is a direct piss in the face. There's a possibility that the Earth's flat. This is geometrically impossible. I've got one guy in the chat that says it's an albedo, a reflection.
Tommy, is it slam dunk proof? This is all you need, right? You can put this in every textbook. Just put that picture, boom, slam dunk. We live on a sphere. Is that right?
You can even use them shadows to triangulate the direction. Sunlight. You can do a lot of stuff with that. You can't just. I mean, a smart person with a high IQ can look at that and go, yeah, that's not more than it's interesting. They would actually say, yeah, that's a massive contradiction to the assumption that the Earth is infinitely flat or flat. It obviously at some point that sun is below the surface of the Earth, which is another contradiction to the flat Earth.
I am not going to continue to perpetuate the presupposition of this ancient spinning space model that's been around since the ancient Greek Flintstones.
The thing about truth,
let him finish. He's in the middle of the sentence.
Doesn't give a shit.
Here's the thing, Tommy, here's the thing.
Truth doesn't care what you
believe. You're a reality denier. You deny reality.
It doesn't matter what
It's very easy to just jump in and say, that's only possible on a sphere.
I'm telling you.
Easy. But guess what, guys? Newsflash. The world is actually very complex. Reality is very complex, guys. And sometimes there's more than just one variable at play. Sometimes it's more than just Earth curve, the ancient Flintstones presupposition that's been around for 2,500 years. Sometimes things are
boo-hoo! I don't like the heliocentric model, so I'm not going to believe things that contradict me.
Why are you so butthurt that the Earth might be flat?
Tommy, was that a real interjection? When he was in the middle of the sentence, you like interrupted to do this. Really? Come on, man. Be a
That's what he's doing. He's repeating himself.
Why are you so butthurt?
I don't want to accept the ancient view of the heliocentric model. He said that already, so I'm just taking a piece out of it now. He's repeating himself.
So Tommy, let's go with your model then. Like you think you believe the 93 million mile sun, correct? That's your stance with this picture that we're looking at.
It's obviously a far distance, yeah.
No, why are you uncomfortable? Stick with. Do you believe the 93 million mile sun?
I'm uncomfortable. I'm
that's
saying
not relevant to this.
It's not relevant to this.
No, this invalidates. This invalidates the flat Earth. The geometry.
The observation that we're looking at in your model.
Hold on. Let me just finish a sentence. This image invalidates a flat Earth. The geometry of a flat Earth means that this cannot happen. Yet we see it. Therefore, the flat Earth is invalidated.
Wow. Okay. So, do you guys believe can light travel through clouds? Has anybody understood that? Like, can light propagate through the cloud?
This is what I'm saying. There's so many potential other variables at play here. To just
name
call it
one
curve is so stupid.
Name one. Name how you can justify the geometry of this shadow.
Well, look, I'm giving you guys a half concession here. That's why I said it's interesting, and that's why I said I want to look at it a little bit more. I will actually take this picture. I'm going to analyze it, and I'm going to see if I can think of another explanation. It's interesting. I'm not going to pretend that it's not like.
Okay, well, we'll have to accept that. Okay, we'll have to accept it. Okay, well, that's a reasonable stance. Okay,
I really appreciate that from you, Red, because I have seen this kind of swept under the rug by many flat earthers. I never had an answer for this. I said, yeah, it's just interesting. You know, I really don't know how to explain it, but it has to have an alternative. I would love to see an alternative presented by you.
Okay, the 93 million mile is not the alternative, sir. How is it illuminating it locally on a 93 million mile sun? Someone give me something for that.
That's a good point. That's not a good point. That's not the great point.
93 million
locally.
Absolutely.
Define locally.
Hold on. The sun rays are coming in parallel according to your model, but why do they seem so centered as if they're coming out from a single source when they're coming in?
Right. This 93 million.
Dumb, man. You know what we're asking.
No, look, it doesn't matter if that sun is 93 million miles away or 150 million miles away or 500 million miles away. The light.
Sir, your assumption is those light rays come in parallel.
No, well, actually, they don't. The sun is a 0.5 degree size, which means they're not quite parallel. They vary by 0.5 degrees.
Observation was based on parallel rays assumption.
Why does it have a bias to illuminate that small region of the clouds and not?
The light rays don't come in parallel. Eratosthenes is the bulk.
Well, it's not quite a point source, but it's a very small source. Why do you have a problem with that?
Look at the clouds.
Are they parallel or not?
They're not quite parallel. No, not from the sun. The light rays are not quite parallel. They're 0.5 degrees.
How not quite?
I keep on saying, I gotta say for the fifth time, 0.5 degrees.
They are near parallel.
Okay, so let's assume that that's true. Why is it illuminating locally?
But that's not
define locally. Define locally. I don't know what you mean by.
Look at the clouds. A piece of it is lit up much more than its surrounding area. Why is that so difficult? Are you guys seeing the picture right now?
Why is it so difficult?
Can I ask you, Chirag? Why do you think the 93 million miles? Why do you think the 93 million miles sun doesn't fit the picture?
Right. Do you not, Chirag? Sorry, Laurie. Sorry, Laurie, to interrupt. Laurie was making a point. Sorry, Laurie, I didn't mean to interrupt you. Laurie was making a point, and I interrupted him. Sorry.
Why would a light source that far away?
Let Laurie make his point. He was asking a question, and I stopped him. Laurie was trying to ask you a question.
So why do you think that the 93 million miles far away sun doesn't fit them?
Well,
it's exactly light rays that are illuminating that region in the clouds.
Right.
The neighboring rays are what Rumpus is saying, roughly parallel, roughly oriented the same way. Why does there appear to be a bias in the clouds when the sun is 93 million miles away?
Okay, I think I understand what you're asking. Are you asking why is it yellow at one end, red near us, and then quite dark to the top of the picture. Is that your question?
There should be a much more consistent interaction with the sun and those clouds.
Is that what so your question is, why is it bright yellow in the distance, red, the clouds are red?
Well, stop playing dumb, man. You know our question, man. It's common.
No, I don't. I'm trying to pin down your question. When you say it's local, I'm trying to understand it. Let me just finish.
I'm going to clarify for you. The question basically is, why does it seem like the light rays are coming from a pinpointed source when they're supposed to be illuminating the entire half of the Earth in perfect, well, according to you, not perfect, but perfect enough that Eratosthenes assumed they were parallel? They're supposed to be coming in parallel lines, but they seems to be stemming from a central point.
Well, what are you saying? What I mean, you don't seem to understand basic geometry.
No. We understand, sir.
No, you don't.
We're trying to wiggle out of this.
No, you don't understand basic geometry.
Thank you very much, Metal Lux Master, for the super chat. He say, red cherry pill picker doesn't realize even below average IQ people can immediately understand the implications of that photograph. Thank you very much for the super chat. I appreciate it.
Was red and then darker as you go past. But if that's not your point, what you're asking
of
why?
Course that's our point, you dummy.
What do you mean? That is your point, but you couldn't articulate that properly, right? So that is your point.
You don't understand because we're getting to a point that makes this 93 million mile thing absolutely
right. So hold on.
I have a very
Can I just say, that is your complaint?
I have a really important question, Ron.
Hold on. I'm just trying to say, is that the query? You're saying?
Of course it is. Any person you just wonder.
You cannot articulate questions. You cannot articulate questions very well. So that's why I try and pin you down. Right. So the question on the table, which apparently is difficult for us, is that it is why is it yellow in the distance on the clouds, and the middle of the picture, the red clouds, and then to the back of the picture, the right hand side of the picture, is the clouds are darker.
That's not my question. That's not my question.
Oh, it's not your question. Okay, so
what is the question? I have a clarifying question here.
Right. Okay. Is that your question, Mind of God?
Of course it is.
Right, well, it's not. Well, apparently it wasn't the same one as part. Okay, right, let's deal with that question. There is a difference in the angle because the horizon there is obscuring part of the sun, and the clouds in the distance there is a line of sight to the clouds in the distance, and it gradually reduces the amount of sun that can see the distant clouds is more because it's not obscured so much because the clouds in the distance are not the horizon for the clouds in the distance is bigger. The sun is not for the clouds in the distance.
Perspective.
No, it's nothing to do with perspective. The clouds in the far distance can be illuminated by the sun, but as the clouds come nearer and nearer to you, the sun is effectively goes lower and lower. So that's why we get a graduation of the light intensity.
Another way
to see left to right. No, one second. That explains, let's say, down the line. Why is there not a uniform appearance across left to right?
Look, let me say one thing.
It's a circle.
One thing, mate. Rumpus, let me say one thing. This guy is just obsessed with the distance to the sun. But like Rumpus had already pointed out, it's irrelevant of the distance to the sun. It's going to be fucking a lot further. But the fact of the matter is, we're confirming the sun is below the surface here. So it doesn't really matter how far the sun is.
Exactly. The sun could be 5 times further away. It wouldn't make any difference to this image.
You know what, Tommy? Hey, you know what, Tommy?
And if you don't appreciate that, you don't understand. So what?
Tommy, they should rewrite all the textbooks. Tommy, they should rewrite all the textbooks and just put this picture in it.
Right. So red pill.
We don't need Eratosthenes ships disappearing bottom up. We don't need Eratosthenes.
Okay. What we'll do then? What we'll do? Hold on. Hang on. We'll take a picture of the flat Earth and we'll stick that in and go, boom, it's flat.
Right. Well, no, because actually it's way more complex.
Red pill. You said my point that I've just invalidated. Mind of God's point. What was your point that I haven't tackled about this picture?
Well, here's the question I wanted to ask you, which is really interesting. Is that I heard that Eratosthenes' observation requires extreme precision for it to have been accurate to calculate the radius of the Earth. But you said that the rays of the sun are not coming in perfectly parallel. And my question is, what that margin of error? If you apply that to Eratosthenes' observations, does it completely take a giant shit all over his observations?
I just did Eratosthenes' observation last month. I hit the radius of the Earth within 100 miles. I had another guy with a longer stick that got it within 1/4 of a mile. So your argument is wrong, Red.
Bobby, first of all, you presuppose the Earth is a sphere, which is fine because that's not the purpose of Eratosthenes. It's safe to calculate the radius. But my question is, do you account for refraction?
Don't need to.
Well, if you take a look at Eratosthenes' original experiment,
Red Bull's getting away. Red Bull's getting away from the sun.
Hold that thought, guys. He was in the middle of the sentence.
Yo, let me finish. Eratosthenes' original observation setup was he had the sun at a zenith
red herring
above one city, but the other city, the sun was not at zenith, meaning it was not directly above. So as the light is passing through the atmospheric gradient of Earth's atmosphere, absolutely refraction is
No, hold on. I've got an answer for you, Red Pill.
Carlos, you're making noise. Mute yourself.
The refraction only occurs of any substantial nature.
Wait, where'd Bob go?
Hold on, you're interrupting me. You're interrupting me. You're interrupting me. Yeah, no, well, at least I was giving you the original. Hold on. I'm giving you an answer. I'm giving you an answer, Red Pill.
Well, Bob doesn't know.
Hold on.
Bob, you know the answer.
Let me finish my answer.
Rumpus,
Refraction. Hold on.
Of course, I know the answer, but go ahead, Rumpus.
I've got an answer for you, Red Pill.
Wow, thank you very much, TIG Logan, for the super chat. I really appreciate it. Red Pill philosophy. Boom!
Can I just finish the answer to your question?
Guys, come on. Be adults.
Can I finish my answer, Red Pill?
Save Bob.
Right, can I just I'm going to answer your point. When you're coming near, hold on. Near vertical light rays do not refract. It's as simple as that. Only horizontal rays get refracted. It's as simple as that. So your argument against hold on. So your argument against Eratosthenes is completely invalid.
That's literally what I said like 2 minutes ago. Destroys.
Then why did you bring it up? If you accept my answer,
I'll say it again nice and slow so you guys can have some extra time to find your answer as you scurry around. So listen, Eratosthenes' original observation that in one of the cities, the sun was at zenith, directly overhead. In the other city, it's not at zenith. It's not directly overhead.
I've got an answer for you again. Right, here we go. Here we go again, Red Pill. I've got the question.
Let me finish. That means the light is coming in through the
another angle. Yes, it's not there.
Stop. So absolutely, refraction must be taking place when it's coming in at that angle.
Red Pill, I have an answer for you. I have your answer. Refraction only occurs near the horizontal. Anything above about 15 degrees above the horizontal, it's zero.
The horizontal of what?
Your local horizontal refraction only occurs if you're looking along the horizontal of your
refraction occurs when light passes through a density gradient.
Yes, but when you're coming vertical, are you not aware that if you were to shine a light directly vertical from, say, water to air, it would not refract anywhere near vertical? Refractions are very, very slight. And in the air, because the density of the atmosphere doesn't change very much, or at least not the only time you get substantial refraction is near the horizontal. Anything approaching above about 20 degrees. Hold on. Anything above about 20 degrees, there is no worthwhile refraction.
Can you let Bob finish now, though, please?
The parallel rays of the sun, because they allegedly
hold on. Let Bob finish.
What?
Let Bob say something, because you asked the question to Bob. He wants to.
Rumpus is talking for Bob, so
I know. I'm
sure Bob would like to speak.
So let's see what Bob's saying.
Yeah, Bob would
like to. If Rumpus wanted to Rumpus, let me respond to Rumpus.
Okay, but don't Rumpus. And then
the light of the sun is coming in parallel according to your model.
No, it's not.
Oh, well, that was the presupposition required. That was nearly required for Eratosthenes' observation. So thank you, Rumpus, for debunking Eratosthenes.
But it's not a significant factor. 0.5 degrees.
Oh, it's not significant.
Rumpus, he ain't going to get it. He ain't going to get it. You explain it, he won't understand. You're going to have to let him think that he's one. You have to let him think that he's one. He ain't going to understand. You have to let him think he wants.
Right. Red Pill, the angle, the fact that the sun.
Where they say that.
Hold on. Let Bob finish.
Right, the angle of the sun, the fact that it's 0.5 degrees does not mean to say if you decide on your little stick, Eratosthenes one that's not vertical, he can take the top part of the shadow rather than the bottom. So he can allow for that. So depending on which one you pick, you can allow for the non-parallel nature of the sunlight. Anyway, go ahead, Bob.
Yeah, so basically, Globers have admitted that Eratosthenes' experiment must be done with extreme precision to get an accurate result. So any type of a deviation from how parallel the rays are, in my view, is a complete destruction of Eratosthenes' experiment.
Well, let's help Bob allowed for it. Bob allowed for it.
I'm not going to talk if people are going to keep talking.
Go, Bob.
Okay, that's fine. I have a comment then. Why are we in 2019 putting sticks in the ground?
Talk, man. He's waiting ages to speak. Nobody's allowed Bob to talk. Let's let Bob.
Tommy, you're cool with sticks in the ground in 2019, sir?
Can we just let Bob talk, please? Because everybody else had to go.
Yeah. Let's let
Bob, you have the floor.
All right. First of all, I did Eratosthenes' experiment with Blue Marble Science in Tennessee. I was in Michigan. I did it with a 7-inch builder's square and hit the radius of the Earth within 100 miles.
Did you account for refraction?
Don't need to.
Why not?
Rumpus has already clearly answered that.
No,
Would
he
you like me
didn't.
to repeat
No,
his
he didn't.
answer
In
to
fact,
you,
I wasn't
Mr.
allowed
High
to
IQ?
respond to him.
All right, I will repeat Rumpus's answer to you. Refraction at the near vertical is inconsequential. When it gets towards the horizon, you can get a little bit of refraction. All right, but when you're dealing with angles of 45 or over 50 degrees, you're not going to have any significant refraction. And the fact that we can prove that is the fact that there were 2 different angles, one in Michigan, one in Tennessee. And they did 2 things. One, they confirmed the radius and the circumference of the Earth very close to the accepted values based on doing a shadow on a roofing square 7 inches tall and a paint stick. Second,
sounds real precise to me.
It was pretty darn precise. Did you do it?
Just let him pontificate. Let him pontificate. Just let him.
No, I would probably use something that requires a few more brain cells, sir.
Well, you don't have the brain cells to figure out how to do it with a builder.
Where did you go to school?
Now, do you?
I'm going to go ahead and share my screen. I'm going to go ahead and share my screen. Sharing screen.
You guys
okay,
can
check
have
this out, guys. This is from flatearthinsanity.blogspot.com, a flat Earth debunking pro globe website, and they say right here, simple proof for convexity of Earth. Flat Earth disproved. And they say, what are the requirements if you want to redo Eratosthenes? What are the requirements if you want to redo Eratosthenes' experiment? Well, that's not.
Did you ignore everything that Bob said? Did you just ignore everything Bob said and just talk a load of bullshit?
All right, so measurements.
Red pill. Red pill. Did you just ignore everything Bob said and just talk a load of shit?
Tommy, he's putting sticks in the ground, dude. We don't need to even talk about that.
Hold on. Right, did you ignore everything he said and talk some bullshit about some YouTube video?
Because right here, according to Flat Earth debunking website, since you cannot get any of these absolutely perfect, this will introduce a small amount of measurement error. So you need to be very precise if you want to perform the experiment and be able to rely on the result. Bob just said that
he got an accurate result.
Is a real factor, and it could. So the point is, you have to be so precise. And if there's any refraction,
we've had it. You've now had it explained to you 5 times.
All right,
you've had it explained to you 5 times. The refraction of the light is near vertical. Why don't you understand this?
First of all, Rumpus, you said the light doesn't come in parallel.
Yes,
vertical and parallel are 2 different things.
Yeah, but they're not coming in parallel. Hold on, I've got an answer for that.
Rumpus, stop.
Bob, does it come in parallel?
You cannot say something in less than 10 words. Don't say it.
Well, I'll do what I like, I'm afraid, Bob. I'm afraid, Bob, I'm going to do what I like. Red pill. The light, when you get so this 0.5, he's done a runner, has he?
No, I'm right here.
0.5, right, 0.5 degrees. You can take an average. So the fact that the in parallel does not mean that's a problem. If you can work out what the average position is, it means it's still not a problem. So the ray parallel issue you're raising is invalid.
Okay, so there, I'll just read it again, because you said that the light rays do not come parallel. But according to this, since you cannot get any of these absolutely perfect, this will introduce a small amount of measurement error. So you need to be very precise if you want to perform the experiment and be able to rely.
Okay, we heard it already.
Are you done yet, Red?
Red Pill, we've heard it already. You have to be really precise. You have to be really precise.
Rely on the result.
You have to be really precise. We get it. Get it. We heard.
You're not letting me finish.
Because we heard you've said it already.
No, but let him finish, bro.
1,000 times because you don't let me finish the sentence.
Do it once more, just in case no one heard it.
Since you cannot get, this is from a pro-globe flat earth debunking website, since you cannot get any of these absolutely perfect, this will introduce a small amount of measurement error. So you need to be very precise.
No one's disputing
I
this.
haven't finished. I haven't finished.
You said this 5 times now. We're not disagreeing with it. We agree with this.
So let me finish.
We agree with this statement.
Jose, can you control the rumpus?
You've said this 5 times. I haven't repeated something.
No, I never get to
Rumpus
finish
is a unique animal, uncontrollable. Rumpus, hold your verbal diarrhea and let people finish their sentence, man.
Very precise if you want to perform the experiment and be able to rely on the results. So if you need to be very precise, I have 2 questions. What does according to Rumpus, non-parallel rays of light coming in, while the observation itself requires the presumption that the light rays come in parallel, how does that affect the very reliable observations? And number 2, refraction, which you guys have not debunked, because refraction is the bending of light through a density gradient. The atmosphere is density gradient, and at one of the 2 positions / cities that Eratosthenes is doing the experiment on, the sun is not at zenith. It's not coming straight down. It's coming in at an angle.
Doesn't need to.
2 questions. Thank you.
Yeah, they're both invalid. The refraction issue is only an issue when you're close to the horizontal. Go on, Bob.
Do you want me to address the questions?
Yeah, you're in a petulant mood. You get on with it then.
Red. What is a degree of precision that is satisfactory to you?
Well, yeah, I mean, obviously, according to your side, it needs to be extremely precise. So
what define extremely precise? Have to be.
Better figure out this problem with Rumpus saying that the rays.
Forget about Rumpus. Just answer.
I don't care about Rumpus. Answer my question, Red. What is a sufficient degree of precision for this measurement?
Are the rays of light coming in parallel or not?
Doesn't matter. Answer my question, not his. My question, Red.
For the experiment, what are you talking about, Bob?
I'm asking you, what is your definition of a degree of precision?
I went out and did it, bro. You say you presuppose the sun rays come in parallel. Rumpus says they don't.
I'm going to say that they're in parallel.
Okay, well, then you just answer the tolerance then. It depends on how much that assumption
answer
holds.
The tolerance question that I asked you specifically, Red. What is good enough precision for this test?
Do you know the answer? You did it yourself?
Yes, I'm trying to find out if you know the answer because I don't think you do.
No, I don't. I'm reading your website here, your little consensus cult website here.
All right, then I will be more than happy to give you the link to the exact test. Now, Jose, may I share the screen and I will demonstrate this?
Go ahead.
Nice. 2 major variables that are not known is the
conversation. Let's keep it nice. We're on track right now. Let's all just have a nice debate for once. Nice, not an argument.
Yeah, I let it roll. It's over 2 hours. I usually keep it on 2 hours, but I'm letting it roll because I'm off work today. And I talked to my boss, hey, you know what? I got a really cool panel, so let me roll the show. She said, yeah, do your thing. So I'm going to let it roll another 10, 15 minutes.
We're getting to an interesting bit now. Let's look at your screen.
Can you see my screen?
Yeah, you're presenting, yes.
All right. This is the setup that I personally use. This is a 7-inch builder square and a paint stick. And as you see, I have a level. And you can actually see me doing it right there. And I'm measuring the shadow.
Mm-hmm.
And then we do the calculations. Here's the math for it. Mm-hmm. That was my determined latitude. My actual latitude is a little bit less than 1 degree less than that. Then we compared it to this 73-inch stick with a shadow in Tennessee. And as you can see, they're marking. See, it's got a little nail on top to be a very precise one.
Was it a humid day? Do you think there's a lot of refraction that day?
I don't think there's any refraction. None.
Wow.
All right.
For the globetards.
Instead of trying to red hair, just
all right. I'm not listening. I'm not interested in red. There is no refraction that
science
is note on
red pill. Try to pay attention.
You're interrupting him, Red Pill. He hasn't finished.
Because it's nonsense.
It's not. It's
let the man finish his nonsense then, if it's nonsense to you.
Go ahead. Come on, let's go.
Okay. right here, these are the locations. You see there's two locations. There's location A in Tennessee, and there's location B in East Tawas, Michigan. Here are the lengths of the sticks. Here are the length and the angle of the sun. Now notice that the angles of the sun here match very closely to his angles, and my angle of the sun also matches very close to my latitude. Okay, here are the error rates and the degree of errors. It's less than 1%. Well, just slightly over 1% right here. Is that what you would consider precision, Red?
Well, your numbers presuppose refraction isn't a problem.
Error of 1%. Do you regard 1% error as accurate?
Everybody be quiet. I was talking to Bob. Everybody
do you regard an error of 1% as accurate?
Rumpus, please. Red, here is my latitude. This is a known position on the Earth. Here is what I got. There is my error with a 7-inch stick. There is his error with a 73-inch stick. Is this adequate precision for you, Red?
Citation.
Is that a yes or a no?
Wow, I didn't even get a second through. Wow.
You're not answering the question. Answer the question.
No, Red. That is
no.
A yes or
That's
no.
the thing. I don't answer loaded questions from a cult member.
They're not loaded questions. He's explaining to you how it's done, showing you what the numbers that he's got. If you don't understand
Bob
them,
didn't answer my question. I asked him if he included the potential error-inducing consequences of refraction in his.
I've answered that twice. Now I'm going to answer it a third time for you. Please let me talk.
I wasn't talking.
Red asked me a question.
Tommy, mute your mic, man. Mute your mic. Everybody mute your mic, but Red Pill and Bob, man. Let them talk.
Now, I've answered your question, Red, twice, and I'm going to answer it for a third time. I am not taking into account any refraction, nor am I taking into account any non-parallel sun rays. This is the result that I got without taking those into account. Do you agree that that is a reasonable degree of precision?
Oh, so your experiment ignores reality. Wow.
All right, there's going to be a yes or a no answer out of you, Red. One way or the other. I'm going to pin your high IQ ass now.
Bob, you've asked me enough questions. Here's a question. Do you have any citations proving that light doesn't refract through a density medium called the atmosphere?
Yeah.
What's your citation for that?
Yeah, at this angle, yes. Plenty.
Oh, at that angle.
Wow.
So it goes through hundreds of thousands of miles of Earth's atmosphere and doesn't refract at all.
Wow. Thousands of miles of Earth's atmosphere.
It sounds like an oversimplification to me. Something
when it's near the vertical or even well above the horizontal, it doesn't refract. It's very simple. When it's above the
now, am I going to be allowed to finish presenting? So I just want to let them go.
Something of Flintstone Stone Age, man, like Eratosthenes.
It should be one-on-one.
You're ignorant.
Rumpus, it should be one-on-one here for real.
That's a stupid test, man. That's a really stupid test.
Hey, do you think Eratosthenes even knew refraction existed back then, thousands of years ago? Probably didn't. It's probably why I didn't include it in his observation.
But hey, can I ask a question? I haven't said anything in a while. By what percentage do you think the results should be affected because of refraction?
Well, here's the problem. Bob's error margin doesn't even include refraction, so it's completely flawed from the get-go. Refraction.
No, answer my question. By how much? What percentage?
You're literally relying on light, according to your model, that's coming from 90.
Okay, so Red, you don't know then. Okay,
you
don't know.
Hundreds of thousands of miles of Earth's density. You guys say the light isn't refracting at all, even though it's your.
Right. Okay. One more thing. So you say that's going through atmosphere.
We established that the sun is actually 93 miles away.
Your go-to argument when you can see things further than they are, but now you're going to discard refraction. It's embarrassing. You guys are done.
Pill, don't you understand? Pill,
now, may I finish my presentation or not?
All right, let's go ahead and get the floor to Bob. Go ahead,
I would
Bob.
love to see the presentation finish.
You got to include refraction.
No, I don't.
Yeah, you do.
Now here is the calculated distance to the sun.
It's a waste of time. It's not accurate to reality.
Then you should leave.
Yeah, you really should, Red, because I'm a little tired of your high IQ nonsense. Hail Satan, get a Capella.
All
Now,
welcome here. All welcome.
here is the error in measurement. Here's the actual error in measurement right
Bob
here.
said I have a high IQ. Cool.
Yeah, I'm humoring you.
Thank you.
But here's the actual error in measurement. Now, this is the measured shadow, calculated shadow. And as you see, the error in measuring that shadow is actually quite consistent. Now, here is the error in miles of the radius of the Earth based on a 73, a 24, and a 7-inch stick. So you see the smaller the object, the more error there is. But that's a 110-mile error in the radius of the Earth with a Builder's square. Okay. Now, you mentioned refraction. Refraction is inconsequential on near vertical light. It's consequential when you are dealing with light coming from the horizon, going through the Earth's atmosphere where you have temperature layers.
How far apart? How far apart were your locations?
Right here.
Was one of the locations with a zenith sun?
Yeah, the equator.
Okay, and how far apart were the cities?
Why don't you look at the table right here? I'm showing you.
Do you mean, can you give me maybe a miles or a kilometer amount?
Yes, it's 2,500 for Tennessee and 3,000 for Michigan, roughly.
All right, and one of those has a zenith sun.
No, the equator has the zenith sun. It's do you know what a spring equinox is?
Yeah, well, are you literally doing Eratosthenes' experiment with a zenith sun?
Yes.
Okay, that's fine. That's cool. Just confirming, just making sure.
And we're doing it with 2 locations away from that zenith sun, unlike Eratosthenes' 1 location. Now, you know what that happens? What happens when you use 2 locations? When you attempt to triangulate the sun, which you can try and do with 1 location to get the sun, it doesn't work when you use 2 because the Earth, my friend, is a sphere. And here you see
this non-linear function.
Right there.
Right, that's what you guys
there's
claim.
the calculated distances to the sun right
that's
there.
what you guys claim, which I don't buy, obviously.
There's the numbers right there. Now, if you were high IQ, you look at those numbers and realize there's a problem with the flat Earth.
The problem, Bob, is that you're presupposing the Earth is a sphere, and you're presupposing that the light rays come in parallel.
I presuppose nothing.
Yes, you do.
Now, here are the numbers.
You presuppose the light rays are parallel.
And you can prove that. That's a measured amount.
Right, and now we got to get into that now, don't we?
That is a measured amount.
Trust some Flintstones guy from thousands of years ago that he knew.
How can you, Red, how can you today determine that the rays from the sun are parallel? What tests can you do? How well do you understand optics to be able to design a test to show that?
Let's not deflect from what we were talking about a minute and 30 seconds ago, which was refraction through the density gradient of the atmosphere.
I've already told you
answer that. I can't.
Now you're bringing up parallel rays from the sun. I want you to tell me how to
test that the rays are parallel. I cannot.
You told me that one of the locations had a zenith sun, but the other one obviously does not, which is actually how Eratosthenes.
There are 2 that don't have a zenith sun.
That's fine. It doesn't matter how many. My point is.
Yeah, it actually does.
The ones that do not have the zenith sun has a sun with light rays coming in at a certain angle through the density gradient of the atmosphere.
Yes, Red. We've heard that 6 times. How many times do we have to tell you it is inconsequential?
Right. Consequential if it's coming horizontally through, but it isn't coming perfectly vertically through now. It's actually a certain amount at an angle. And the question that you need to figure out is how
calculate it for me. I'm saying that it is
inconsequential is taking place.
You're just talking over me, Red.
No, you're talking over me. I sat down and let you.
Boys, all right, boys, calm down. From listening to the discussion, Red, you need to.
Tommy, what are you doing? You say calm down. Yeah, okay. You say calm down, but shut up then.
Tommy, let me respond because I sat in silence while he presented his data. He's saying that it's inconsequential, the refraction of light, because it's not coming in horizontally. But it's also correct.
How many times does he have to tell you that before you understand it?
Rumpus, let me finish. But it's not coming in perfectly vertically either.
It doesn't need to.
So the question,
what don't you understand? Hold on. Hold on. What don't you understand about the refraction is only an issue if it's not horizontal. If it's horizontal, if it's anything above, if it's anything above 10 or 20 degrees, there is no refraction. How many times do you have to be told this? It can go all the way from 20 degrees up to 90 degrees, and there's no refraction. You only get any sort of refraction below about 5 degrees from the horizontal. Anything above that, and you can ignore it.
All right, I'm going to answer Red's question here.
Give me a citation.
Right here.
Give me a citation.
There you go, Red. Now,
Rumpus, give me a citation for that, please.
Right
I can
there.
show you a graph. I can show you a graph.
I want to know where that
right there. There is your refraction difference. 0.02%.
Oh,
now I want to hear you say, Red, that you agree. Actually, it's almost 1/100%. 1.15%. I want you to tell me, Red, and everybody here, to show that you are intellectually honest, that that is inconsequential.
Well, first of all, according to the Globe website and Flat
No,
Earth.
stop.
Oh,
Right
answer
there.
the question.
Why would you interrupt me? Wow.
Answer the question.
Answer the question.
But I am going to answer the question.
No, you're not. Yes or no?
How do you know if I when I haven't?
Because it's a yes or no answer.
It's not yes or no. Why do you guys try to simplify things? Are you guys stupid?
Guys. Yeah,
Let's represent.
I know you guys.
Miles difference does this represent on the Earth, Red?
I'm sorry, I couldn't hear you because there are 8 of you talking at once.
How many miles does this error right here for refraction represent on the Earth?
Bob, did you not even know the percentage error margin that's allowed in your little experiment? Do you not even know what it is?
Yeah, I do. I'm asking you another question. What is the error in miles of that?
Error in miles.
All right. Now, how many miles of error between my actual location on the Earth and the actual location per the refraction index right here, the angle of refraction? How many miles difference does this represent?
Let me get some
my size of my estimate of 45 degrees versus 44.9885 degrees. How many miles on Earth is that?
Let me get some clarity, Bob. Okay, so.
All right, I'm going to answer if you answer for you.
Bob, I'm trying to understand.
Trying to answer a question.
Bob, I genuinely want to understand where you're coming from, but can I ask you some questions about what you presented on screen?
No.
All right, that's fine. You can just talk to yourself if you want.
Right, it's been explained to you repeatedly. The refraction.
No, it hasn't. Now you guys are finally giving some numbers, and I want to know what the numbers are.
The refraction is not an issue. For instance, astronomers. You can look. I can show you a graph showing what astronomers consider to worry about a fraction. Can I just finish?
There's the error. It's 7/10 of a mile.
Sorry, Rumpus.
Bob, you're just putting numbers on.
I just think we should ignore Red Pill and talk to the other guy because Red Pill.
I just want to make one final punchline. He asked for citations earlier. Astronomers, for instance, don't like to observe stars close to the horizon, but immediately they get above about 20 degrees, they do not worry about refraction, and that's because refraction is not an issue for any observation above about 20 degrees. Sorted. Because you don't, not ours.
Well, if that's true, then that's fine. And that's why I wanted to ask Bob for a little clarification on the numbers he was putting on screen. Bob, can you put those numbers back up? That screen with the Snell's law calculator, could you put that back up, please?
It's already been up. What's your answer?
Well, Bob, I'm not just going to answer your question out of context from the experiment you performed. I want to know how the numbers you put up apply to the experiment you performed. Please
show me a citation. Now explain this. Now do this. Now do that. When does it end? When does it end?
Don't you understand the results that he got were incredibly accurate, which means that all the approximations or the error measurements. Hold on, I was only half. Hold on, Red Pill. You stopped me about 5 words in. the results that Bob got means that all the errors that he was dealing with were small or close to negligible because because the results that he got were accurate. So it means all the things he decided to worry about or not, he made the right decision.
That's not what I'm asking.
Let me get a word in really quick. Sorry to interrupt, Red and Rumpus and everybody. There's Al K. He built a new channel, 1v1 Earth Debate. He typed in on chat over here, and he's planning on doing one-on-one debates, discussions, anything. So contact Al K if you're interested in having a one-on-one close discussion, very neutral and unbiased, so people can be heard on that sense. I'm gonna try to update the description box, and I add the channel 1v1 Debate. So please check out Al K for more information. Carry on, guys. And I'm gonna roll a few more minutes. I gotta shut it down. Mario, go ahead.
Hey, Bob, be so kind to put that Snell's law calculator back on, please. I really appreciate it if you would. Okay. Look, this is my question. My question is, I want to know the variables you punched in there. What are those in relation to the experiment? I only just saw your experiment, Bob. I only just saw the tables that you performed, that you put forward with all the numbers and shit. So I'm trying to crunch these numbers in real time. I want to know what this Snell's law calculator, what are those numbers? Where were you getting those from? How do they apply to the little?
All right. First of all, you have seen it because you've put snide comments on it. So you should have paid attention the first time.
Snide comments where?
On the video.
That's fine. But maybe I didn't.
Or you should have paid attention when you put those comments in. Second of all, do you know what the refractive index of a vacuum is?
No.
All right, it's 1. What is the refractive index of air?
Don't know.
It's 1.0002.
Wow.
The angle of my observation, which is higher than the angle of the observation in Tennessee. All right, there's more of an angle for mine than there is for his. He's closer to the equator than I am. So I used the biggest error that I could get, which would be my observation of 45 degrees. Based on the angle, Snell's law and the angle of refraction, that gives me 44.9885. Now, if you look at my numbers right here, now, by the way, that represents 0.7 of a mile error in positioning on the ground. Now, if you look at my numbers right here, we're looking at a 1% error for me. Mm-hmm. My location was inaccurate to approximately 80 miles. North and south. So this angle right here, the error due to refraction, is what's the word for it? Consequential. It is easily ignored because it has no bearing whatsoever based on the precision of the rest of the experiment. There is the result of the rest of the experiment. I had 110 miles error.
Let me ask you, could you go back to the Snell's law calculator, please? So let me ask you, you say that the refractive index of air is 1.0002, correct?
I think that's what it is just from memory. If it's 1.002, then that would be different.
Does that vary at all as the sunlight passes through hundreds of thousands of miles of the density gradient of Earth, which pressure increases as you get closer to Earth's surface?
Bob, this test is retarded. Can we talk about
hundreds of thousands of miles of air and pressure gradient? How big is the atmosphere, Red?
Well, the most recent numbers say it extends.
How big is the atmosphere that has air in it, Red?
394,000 miles, according to the latest numbers.
How big is the atmosphere that has air in it that you can breathe?
Don't know.
Oh, probably 10 miles, maybe.
Oh,
actually,
so
you would start. Actually, it'd be probably less than that. That would be 50,000.
28,000 feet.
Hang on, the light isn't only going through air particles; it's going through the entire atmosphere. So again, my question is, how does the refractive index stay constant at 1.0002, passing through a density gradient of air of 10 miles?
I'm going to stop you right there because you're going.
Even if it's 10 miles, that is a gradient. So it's actually It's
You're
not
going through the absurd here now, Red, and I'm not going to sit here and just let you do it. Do you agree, Red? Hey, high IQ guy.
Science isn't absurd, Bob.
No, your interpretation of it is
with your Snell's law calculator, saying that the refractive index of air is 1.002.
Bob, that's
it's a constant. It doesn't change. There isn't variables. The atmosphere gradient isn't varied.
Rumpus, you should say something, man. That's not rigorous, dude. Speak up, dude. That's pathetic.
Bob's been perfectly rigorous in everything he's done.
I'm asking,
did you understand?
Does the refractive index stay at 1.0002 the entire time?
Stop, Red. You do understand that the refractive index of a vacuum is 0, correct?
Simplified non-argument is what this is. You pulled up a little Snell's law calculator with a constant refractive index. It's a joke.
All right. You don't understand refraction, Red Pill. You do not understand refraction. You're an absolute idiot.
Red, you guys don't understand nuance.
Are you going to get the answer that you're asking for?
What's a good? We haven't even gotten started here, bro. You need to show me. First of all, you need to show me. You're talking about refraction. Let's talk about how
you've had so long to talk, right? You've just talked the whole show talking your nonsense. Like, can we just have a break from Red Pill?
Yeah, he's talked more than anybody else by a factor of 2 or 3.
And he's just chatting shit as well. Like,
yeah, exactly. I gotta jump in. I really appreciate it because he's not here every day. I mean, I know he's got a big channel and he want to maybe share some of his interaction in here in his channel, and that way we can grow and we can have more the diverse panel, like for real. You know, you guys got to understand that. And I really got to round up the show. I'm gonna give everybody a chance to speak. Give me your final thoughts on the show, plug your channel, do anything you want. So I'm gonna go down my list in the Hangout the way I see it, and everybody got a chance to speak your piece. After we do the roundup, I will close the Hangout. That will kick me out of the call, but the Hangout will be running offline. If you guys want to keep talking offline, you're welcome to stay in the Hangout. We're going to start with Bob. Go ahead, Bob.
Take care. Thanks for having me.
Thank you for being here. I appreciate it. Carlos.
It's 2019. Father Earth still don't know perspective. Thank you.
Thank you very much. I appreciate it. The man of God.
Okay, so let me summarize what's going on here, Jose. We're speaking to a doctor, Bob, 2019. Sticks are in the ground. Huge errors in his test. 93 million mile assumed sun. One number is documenting and articulating the distance, the difference between that sun and the Earth. And this is what we have going on here. So if that's not a flat Earth proof, I don't know what is, man. Peace.
Thank you very much. I appreciate your support too, man. Always. Go ahead, Laurie.
Saying sticks in the ground is not actually any kind of debunk. That's just silly and non sequitur. His test was actually rigorous. And the final thing, hats out to Red Pill. I actually appreciate guys doing it.
Thank you, Laurie. I appreciate it. Who do we have here? Seek and Find. Go ahead, brother.
Thanks, Jose. I think it was a pretty interesting conversation. Appreciate you having me on, and I think Mind of God summed it up pretty well there. Thanks again.
Thank you for coming, man. Tommy.
So yeah. I think Bob's presentation was extremely good. I think Rumpus was amazing today. Does take a lot of time to explain some things sometimes, but he, was great to taking time out and allowing others to speak. So it's really impressive. Red Pill, just mate, you just need to listen to what people are saying. They're giving you better explanations than you're bringing to the table, and no matter how much we repeat something, you don't seem to get it. That only the horizon and 20 degrees from that point will reflection come into place. And even if you don't agree with that statement, at least acknowledge what people are trying to say and why it's irrelevant. Then we can make more progress, and maybe you could learn some more and use the IQ that you claim to have. Good. Thank you all for having us.
Thank you for being here, bro. Red Pill.
Yeah, I want to say thank you, everybody, for the debate. I really appreciate it. Even the people I disagree with, I think we should be able to disagree and not hate each other. But sometimes when you're a smug atheist and you're part of a religion and you don't even know it, you think you're all high and mighty because you think you're the ultimate arbiter of truth when you're just another cult member and you don't even know it. But again, yeah, thank you to everybody. Yeah, I'm just, I think you got to look into things very detailed. You can't just pull out a Snell's law calculator with a refractive index that's a constant number and saying, oh, that's a refractive index of air, yet it's a density gradient. The density of the air increases as you get closer. So it's just ridiculous to use a constant value for a dynamic atmosphere density gradient.
Where can people find you, Red?
Yeah, every Red Pill Philosophy on YouTube. It's there. But what everybody really needs to go do is they need to go look up the YouTube channel Life is Short. Just type in Life is Short angular resolution into YouTube, and you'll find his channel, and you'll be surprised by the incredible high IQ presentations that this individual is doing. I mean, it's amazing what happens when you stop presupposing that everything is just caused by curvature. Thank you.
It was fun taking you apart, Red.
Thank you very much,
Sorry,
Red.
Bob.
I appreciate you stopping by.
You talked, and so you can just stop with a little.
Yeah, hold on, Bob. You already spoke. Right? Wait for the end. Thank you very much, Red. I appreciate you showing up, brother. The Rumpus, go ahead.
Right, hello. Here's a graph. Actually, this is one I'm familiar with, and actually it was supplied also by Flatty, I think, in the chat. Also linked me to it. This one I actually include myself. And here is the refraction versus the angle. And after about 10 degrees, I think it's actually at 5 degrees, I think astronomers decide they don't really like, although you can actually allow for it. You get these, this is a refraction arc minutes, which is a very small angle. But as you can see, after about 10 degrees or 15 degrees, it effectively is not changing. And we had to go through, I don't know, Red Pill saying something, he had to be told about 10 or 15 times that the refraction is only initially near the horizontal. He didn't understand what horizontal was. He had to ask me what that was. The guy is an absolute moron. And then he also, despite being told this and having evidence there's no refraction issue except near the horizontal, he then started to talk about, oh damn it, I forgot what the other thing was. He mentioned. Okay, well, he's an idiot, moron. Doesn't know any science. He doesn't know Snell's law. And the argument he's just using about the turbulent atmosphere, completely irrelevant. This is the graph that counts. He doesn't understand refraction or very much else about anything. He's a moron.
Thank you very much, Rumpus. I appreciate you being here. All right, thank you everybody in the channel, in the panel.